Okay, so today's lesson is going to be on the product rule, which is a way to find the derivative of a product. So if you're trying to find the derivative of two functions that are being multiplied together, there's this way to do it called the product rule. And if we look at it, it's sort of like a formula. The derivative of the product of two functions is going to equal the first function times the derivative of the second function plus the second function times the derivative of the first function. So we start off with an example of two functions being multiplied together. And what I'm going to do first is show you how we would find this doing this the old way from our last lesson using just the power rule. So I'm going to start by just rewriting this and foiling it at the same time. So I'm going to say that h of x is equal to the first, or 15x, outer would be plus 12x squared, inner would be minus 10x squared, and last would be minus 8x cubed. Okay, I'm going to combine like terms and write it in descending exponential order, leaving me with negative 8x cubed plus 2x squared plus 15x. And now I'm going to take the derivative using the power rule on each of these three terms. So the first term we get negative 24x squared plus 4x plus 15. Pretty easy. We'll hang on to this answer. And then when we do it using the product rule, let's hope that we get the same thing. Okay, so let's get set up here. This is going to be our first example using the product rule, and I'm going to use the function that we just used a moment ago to illustrate this. So to start, I'm going to make this organizational list including f, f prime, g, and g prime. Whoops, I put one too many primes in there. So let's get this back up. Okay. So think of these like pieces of a puzzle. When I put them together in this formula, I'm going to get the answer. So f is the first function, which is 3x minus 2x squared. The g function, or the second function, is 5 plus 4x. The derivative of the first function is 3 minus 4x. And the derivative of the second function is 4. Now, again, these are all pieces of the puzzle, and now I'm ready to now find the derivative. So this is going to be h prime of x is equal to the first, f of x, or 3x minus 2x squared, times the derivative of the second function plus the second function times the derivative of the first function. So I'm going to distribute, FOIL, combine like terms, and hopefully it'll look like the problem that I did the first way. So we get 12x minus 8x squared plus 15 minus 20x plus 12x minus 16x squared. This is a 1. Okay, so we're going to combine like terms. And in terms of squareds, I've got negative 8x squared and negative 16x squared, which is negative 24x squared. In terms of just linear terms, I've got 12x, another 12x, which is 24x, minus 20 is 4x. And then we finish with our constant, which is plus 15. Now, if we look at this answer and we compare with the answer that we got doing it the old way, we have agreement. They're the same thing. So in certain cases, using the product rule will be quicker. In this case, actually, it was probably easier to do it the old way, but as you do more and more practice, you'll start to get a feel of when you should use one method over the other. Okay. In our second example, we have another situation where we've got a product of two functions, but this time it includes a trig function, so we're going to see how to tackle that, and really nothing's going to be different. We're going to start by making our list of f, f prime, g, and g prime. F is for our first function, which is x. G is for our second function, which is sine of x. The derivative of x is 1. The derivative of sine x is cosine x. So putting these together, we're going to be able to construct the derivative. According to the product rule, we're going to take the first function, which is x, times the derivative of the second function, cosine x. So the first times the derivative of the second plus the second function times the derivative of the first. So that's the second function times the derivative of the first. Putting these together, we end up getting x cosine x plus sine x. So that wasn't too bad. And we'll try another one. Here, the first term in itself requires the product rule, and the second term is pretty easy. So let's just deal with the first term as though it's its own little problem. We're going to call this f, and we're going to call this g. So we'll start by saying f, f prime, g, g prime. Again, this is sort of the organizational piece of solving the problem. F is 2x, g is cosine of x. The derivative of 2x is 2. The derivative of cosine x is negative sine x. So the derivative, according to the product rule, is going to be the first times the derivative of the second plus the second times the derivative of the first. So again, it's the first times the derivative of the second plus the second times the derivative of the first. Now we can't forget about the second term. The derivative of sine is cosine with a negative 2 out in front. So that's going to be negative 2 cosine of x. Cleaning this up, we're going to get negative 2x sine x. And then we've got plus 2 cosine x, followed by minus 2 cosine of x. So these guys are going to cancel out, and our final expression of the derivative is negative 2x sine x. So 2 more examples of how to use the product rule.